Imagine a world where your fate is written before you are even born. A world where your genetic makeup dictates your career, your social status, even your right to exist. In this society, perfection is engineered, and deviation is eliminated. If you're genetically superior, the world is yours. If not, you'll never be more than second class. These are the fears that science fiction has long warned us about. But what happens when fiction starts creeping into reality? The ability to alter human DNA isn't a distant fantasy anymore. It's here. And in 2018, one scientist decided to cross the line between what was possible and what was ethical. In November 2018, a scientist named He Jiankui made international headlines with what seemed like a groundbreaking announcement. He claimed to have created the first ever gene-edited babies, twin girls he called Lulu and Nana. His goal was to make their genomes resistant to HIV infection by altering a gene known as CCR5. And, well, to say this sparked controversy would be an understatement. The CCR5 gene is kind of like a molecular gateway that the HIV virus uses to infect our immune cells. By disabling or modifying this gene with a tool called CRISPR-Cas9, He Jiankui aimed to create an immunity shield of sorts for these babies. It sounds revolutionary, right? But here's the thing. What happened wasn't perfect. Not even close. In one of the twins, both copies of the CCR5 gene were only partially edited. For the other twin, only one copy was altered. And even worse, not all the cells in their bodies were edited. This condition, called mosaicism, means that some cells carry the changes, but others don't. So the question becomes, were these babies truly protected from HIV? Or were their genomes left in a dangerous, unpredictable state? And then there's the issue of off-target effects. CRISPR works by cutting DNA at very specific sites, but sometimes it can miss and create changes in unintended places. These errors might seem minor, but even tiny disruptions in a genome can lead to long-term consequences, things like cancer or other diseases that could emerge later in life. What's worse, we don't fully understand how these changes might affect their health overall. But the fallout wasn't just scientific. His announcement exploded across the scientific community and even into public discourse. Researchers and ethicists condemned the experiment, calling it premature, reckless, and downright unethical. One major issue? Informed consent, or really, the lack of it. The parents involved were promised the moon, but were they really fully aware of the risks to their children? Were they genuinely able to say no? It casts this shadow of coercion that's hard to ignore. Then there's the bigger societal picture. Critics warned that this wasn't just about protecting these twins from HIV. It could pave the way for so-called designer babies, where parents might one day pick and choose traits like intelligence, athleticism, or even physical appearance. It makes you wonder, at what point does medicine stop being about treating disease and start shifting toward human enhancement? And who decides where to draw that line? The backlash was overwhelming. Some even compared He Jiankui to Dr. Frankenstein. The outrage wasn't only about breaking laws or ignoring scientific protocols. It was about the morality of editing the human genome, a legacy that could ripple through generations. These twins weren't just subjects of an experiment. Their genetic makeup is something they'll carry for the rest of their lives. And so, in a matter of days, what promised to be a revolutionary medical achievement became one of the most controversial events in modern science. The ethical violations were undeniable, the risks horrifying, and the implications? Huge. He Jiankui's announcement didn't just cause a moral uproar, it had legal consequences too. Chinese authorities quickly cracked down, sentencing him to 3 years in prison for illegal medical practices. It reflected the weight of what he'd done. He broke both legal boundaries and ethical ones, violating trust not only with the parents involved, but with the entire scientific community. But there's an even more puzzling layer to this. Philosophers started wrestling with this idea of harm. This may sound counterintuitive, but were Lulu and Nana really harmed by what He Jiankui did? Sure, there could have been unforeseen health complications or off-target effects. But the question remains due to a puzzling idea. Would Lulu and Nana even exist without those gene edits? This relates to what philosophers call the non-identity problem. Here's a clearer way to understand it through an example. Imagine a woman named Barbara has the choice between implanting two embryos, one that will develop into a child named Billy with a genetic condition, and another that will develop into a healthy child, Timmy. Let's say, for whatever reason, Barbara wants to have an unhealthy child and intentionally chooses the embryo that will become Billy. Billy's life, despite the condition, is worth living. The non-identity problem arises because if Barbara had chosen a different healthy embryo, or no embryo at all, Billy would never have existed. Therefore, it seems paradoxical to say that Barbara harmed Billy by bringing him into existence with a condition, as the alternative for Billy was non-existence. This same logic applies to gene-edited babies like Lulu and Nana. Without those genetic modifications, it can be argued that they would not be who they are today. Different embryos might have been chosen, resulting in different children being born. From a deontological perspective, basically, the idea that actions are inherently right or wrong, what He Jiankui did was just plain wrong. He violated moral principles, ignored ethical guidelines, and imposed massive risks on these children. But from a utilitarian view, you might ask, did the potential benefit of resistance to HIV outweigh all the risks and uncertainties? Probably not. After all, the process wasn't flawless, and the possible long-term effects remain a giant question mark. But what if the experiment had been conducted perfectly, with flawless gene editing and zero off-target effects? Even in this hypothetical scenario, serious ethical questions would remain. Would it be acceptable to permanently alter the human germline, knowing these changes would be passed down through generations? Should we allow parents to make such profound genetic decisions for their future children? And perhaps most importantly, does successfully achieving a desired genetic modification justify bypassing the established ethical frameworks and global scientific consensus? These questions persist, regardless of technical precision. And beyond the philosophical debates, this sent shockwaves through the global scientific community, forcing everyone to rethink the rules, or lack thereof, around gene editing. Scientists and policymakers started pushing hard for clearer, stricter regulations. They argued that without robust safeguards in place, breakthroughs like CRISPR could deepen social inequalities, maybe even giving the wealthy exclusive access to genetic enhancements. Imagine the implications of that, a kind of genetic divide where suddenly, biology determines class even more than it already does. Now let's fast forward to today. After serving his 3-year prison sentence, He Jiankui has stepped back into the scientific spotlight, this time with a new project. He set up a lab and claims to be working on using CRISPR for somatic gene editing to treat Duchenne muscular dystrophy, a devastating genetic disorder. At first glance, it seems like a step in a safer, more controlled direction. Somatic editing means the changes won't be passed on to future generations. That critical distinction cuts out a lot of the ethical baggage tied to germline editing. But there's still this shadow and skepticism about him and his past choices that's hard to ignore. He Jiankui's actions remain a cautionary tale, a reminder of what can happen when innovation moves faster than regulation. The tools we have today, like CRISPR, are incredibly powerful. They can potentially cure diseases that were once death sentences, but they also carry risks we're, only beginning to understand. Without stringent oversight and proper risk management, the line between progress and carelessness gets awfully blurry. And that's terrifying because the stakes are just so high. And here's the thing. Gene editing isn't going away. The potential is just too incredible. But if we're going to keep pushing these boundaries, we need to rethink how we balance innovation with ethics. What kind of frameworks do we need? How do we ensure that powerful technologies serve everyone, not just an elite few? Gene editing could reshape humanity in ways we can't fully predict. But the question is, will we use it responsibly?